So this third video in elementary algebra in 2.5, which is 2.5c, is going to go over some of the practice problems on page 136. So we'll just go through a few of the homework so that you feel a little bit better about doing some of these if you're having any questions. Numbers 1 through 18 is, for the most part, just plugging in numbers and getting an answer. So if you look at number 16, for example, we have y equals 20 over x. And for a, they tell you that x is 10. So what we're going to do is we're just going to, wherever we see an x, we're going to put a 10 in its place. And 20 over 10, you can get rid of those, 2 over 1, which is 2. Now if you look at the b part, it says, well, what if x is 5? So then we do the same thing. We take our 20 over x, but instead of an x, we put a 5, and 20 divided by 5 is 4. So you get two answers for number 15, and that will be the same with 16, 17, and 18 as well. Now if you look at 19 through 20, it's asking you to solve each of the following formulas for the indicated variable. So these are the ones that sometimes get a little bit tricky. So if you start with 19 and you have A equals LW, and they're saying solve for L, that means they want L on one side. It doesn't matter which side, but on one side of the equal sign by itself. So if we've got a letter or a number multiplied by L, we divide by that, both sides, cancel that, and we're done. We have L equals A over W. So that's what we're looking for, is L. If we get into some that are a little more tricky, like, 24. 24 isn't like extremely tricky, but A plus B plus C, and they want you to solve for B. And that means we have to get this and this off of that right-hand side and move it to the left-hand side. So not too hard to do that because the numbers are both added to the b. So if we subtract that, we have p minus a. We subtract it from there too. Those go away. Now if we want to get rid of that c, we subtract c from both sides, because those cancel. And that's it. We were able to find our b without too much struggle there. Now let's jump to some that are a little bit trickier. In fact, let's go all the way down to number 40. And then we need to solve for h. So if you remember, this is pi. It doesn't really matter at this point if you understand pi or anything like that. It's just, all we know is that 2 and pi and r squared are all multiplied by each other, and 2 and pi and r and h are all multiplied by each other, and they're both added. Okay, so what we're trying to do is get this h by itself. Well, let's find what's furthest away from h. Furthest away is this whole mess right here. And we don't have to separate this. This is one big unit here. So if we just took and subtracted from both sides, and we can do that because right here there's a plus sign. There's no sign in front of the 2, so it's an assumed plus. So this is a plus 2 pi r squared, so we're going to take it away. And when we take it away, that all goes away, and we end up with a minus, whoops, I probably should get rid of that particular a and make it capital. Alright, 2 pi r squared minus a, oops, I already took away the a, God, it's early in the morning, equals, and that went away because we subtracted, 2 pi r h. So we're still trying to find h. Notice these three are multiplied by the h. Now you could divide them by h one at a time, or because they're all three multiplied by h, all three of them are going to have the same thing done. So we just take the whole kit and caboodle and put it underneath like that, and that over that goes away, and our final answer then is a minus 2 pi r squared over 2 pi r. So we did it in minimal steps because we were able to get rid of things a lot quicker, and that sometimes helps. Okay, so continuing with solving for the variable, this is number 44, and that's x over 5 minus y over 9 equals 1. Now what makes this a little bit tricky is that we're trying to solve for y. And what the reason why this is tricky is because trying to get rid of this is not too terribly difficult, but sometimes it throws you a little bit to get rid of that 9. But I'm going to see if I can show you an easy way to do that so it's not so complicated. We'll get into some that are a little more complicated later, but no reason to do that at this point. So what we know is this: we have two terms here because they're separated by a minus sign. So two numbers or letters separated by a plus or a minus sign is a term, or are two terms. So we're going to take this whole term, this whole fraction, and get it over here. So how do we get it over here? Well, there's a plus sign in front of here, right? An assumed plus sign. It's a positive x over 5. So to get rid of it, we subtract x over 5 from both sides. And then we have negative y over 9 equals 1 minus x over 5. Alright, so it's looking a little bit better. We got everything away from here except the negative and the 9. Now, if you remember, a while ago we had, this is an aside here, if we had a number like 2/3 and we had a negative here, that equals, which equals, okay, those are all equal to each other. So we could take this negative sign that we have here and move it down to the 9 instead. We don't have to. It just kind of makes, we are able to do things in a bigger, or in an easier way because we can do more. So we'll just take that off and put the negative down there. Alright, now we have that negative 9 down here. How do we get rid of a number that is being divided? Well, if it's down on the bottom, to get rid of it, we multiply both sides. So I'm going to multiply both sides by negative 9, and that goes away. So we're left with y equals, and I'm going to move this 9 to the front just because it's easier to work with for me. It doesn't really matter. Now I can distribute. So distributing, I get y equals negative 9 times a positive 1 is negative 9. A negative times a negative is a positive. 9 times x is 9x over 5. And the only thing I would suggest is switching these around, just so the x is first. Okay, so this is number 46. And again, we're solving for y. And again, we have this whole term. Remember, a term is separated by a plus or a minus, so this whole thing is a term. So we're going to get rid of this whole term. It's the furthest away from the y. So it's a minus here, so in order to get rid of it, we add it. And we add it. And that gets rid of this whole part right there. That leaves us with a 1/3 y equals 1 plus 1/9 x. Alright, so now what do we do? Alright, we have a 1/3 times our y. We've got to get rid of that 1/3. It's multiplied there, so in order to get rid of it, we divide it. Like that. Cancel those. And remember, we never divide fractions. So let's invert and multiply this. So we'll put 1 plus 1 over 9x. We'll put it in parentheses here because we are dividing, and the entire thing by 1/3. So when we invert and multiply, we invert and multiply times the entire top. So invert and multiply, that means we take the 1/3, turn it upside down, and multiply here. And again, I'm going to put this in the front and take the 1 off the bottom there, just make it a 3. Okay, so y equals 3 times 1 is 3. 3 times 1/9 is 3 over 9. Okay, and then that 3 over 9 there can be reduced. So 3 over 9 can be reduced to 1 over 3. So we get 3 plus 1/3 x. And again, we'll switch those around to 1/3 x plus 3. Alright, so we'll just do one more story problem and then we'll be done. I'm going to jump down to number 66, and it says let C equal 100. And that C stands for degrees Celsius, and it stands for 100 in the formula. F equals 9/5 C plus 32. Okay, so this is the formula you use if you are trying to translate from 100 degrees Celsius to how many degrees Fahrenheit this is. So this is the formula that you use for that. So in order to do that, all you have to do is plug 100 in for C. So we get 9/5, and I like to write everything out before I start solving. Alright, so F then equals 9 times 100 over 5 plus 32. And 900 divided by 5 is 180. So F equals 180 plus 32, which equals 212 degrees Fahrenheit. So that's the boiling point of water in Fahrenheit. That is the boiling point of water in Celsius. So the question was, does the value of F agree with the information in Table 1? And if you look back on Table 1 on the bottom of page 134, the answer would then be yes. So that's it for Lesson 2.5.